Hi guys, welcome to lecture number 1 specifically for PyTorch. So this is a new series for PyTorch, and guys, why I'm making a series because the main idea is I do believe that specifically PyTorch and neural networks, mainly in the form of LLMs, would be the only skill that would be needed in the future. I don't see a lot of you doing a lot of manual tasks, repetitive tasks, because all of it would get updated. But yes, having the fundamental knowledge of PyTorch would definitely be a game changer, since it's gonna help you understand neural nets better and code them better. And generally also, if you have any task when it comes to AI and you are not using an API for that, the obvious choice would be PyTorch only. So guys, if you are new to this channel, you can please subscribe and try to have a look at the content that's already present. But let's just start with the basic introduction of PyTorch. Okay, I won't be going into a lot of theory yet because I want to keep it as hands-on as possible. So see guys, PyTorch is nothing, it's a framework. Okay, essentially it is a library that helps you do ML DL tasks in Python. That's the only introduction that you need to know. Yes, it's being created by Meta. I think this much information to start with is enough. We don't need anything more to start with. So now guys, let's just try to go to our coding canvas and try to see that what we have for today. So see guys, when it comes to PyTorch, you just need to open Google Colab. Okay, you just need, let me just close this. So what you need to do is you just need to open Google Colab, and then you can just start from here. Okay, obviously I'll be sharing the Colab notebook link with you guys. So guys, part 1 is essentially understanding tensors. So today we'll be talking about tensors a bit. So see, tensors is the fundamental underlying data type which PyTorch uses. Okay, so every framework must have a fundamental and an underlying data type as well, because guys, in ML, okay, in ML and DL, having a fundamental data type is of utmost importance. I'll explain you why. So let's just go over here. Okay, I think it's not working. Let's just close this. Yeah. So see guys, why I'm saying this, that essentially why I'm telling you that is that tensors are fundamental data type. So what happens in ML and DL based tasks is that you need to do a lot of optimization. What does optimization mean? It essentially means optimizing a function, optimizing a function with respect to some parameter. Okay, let's not go into very depth of it, but you require to do a lot of mathematical operations, namely addition, subtraction, division, and other series of complicated actions as well. So for all these mathematical operations to take place in the backdrop of PyTorch, the underlying data type is nothing but it's tensor. Okay, so it's more like, let's say you have a function y is equal to x square, and you want to compute the derivative dy by dx is 2x. So all these things, right, happen backend, and in order for the machine to do it safely, you need tensors. Okay, so in our school we used to maybe say that there's a function called x square minus 2x, and someone is asking us to find the minimum of the function. So we go by dy by dx is 2x minus 2, and then we equate this to 0, and then we just take 2 common and we get x as 1. So this value, this function will take the minimum value when x is equal to 1. So these kind of calculations usually happen a lot when it comes to PyTorch, specifically in the backend. So guys, see, for all these type of calculation, PyTorch needs tensors. So that's the role of tensors. Now let's just switch to our coding board again and let's just try to understand it further. So now we are good with it, so we know what is a tensor and how it's going to shape out. The next thing is, guys, how do we create a tensor? So see guys, this is how a scalar tensor gets created, this is how a vector tensor gets created, and this is how a matrix gets created. So I think guys, this is very simple. Torch dot tensor, you can understand it. Now guys, we can do basic mathematical operations on tensors. We can add them, we can do element wise multiplication. If you'll see, how does tensors look? See, that's how they look. If you will do any sort of calculation over here, for instance, you wish to add them, so it's more like this is the tensor 1, this is the tensor 2, and you add them. So 1 plus 4 is 5, 5 plus 2 7, and so on. So you can understand multiplication is more like 4 into 1, 5 into 2, 6 into 18. So okay, this is just the underlining block of PyTorch, that's the tensor. So you can just try to look at this basic tensors and basic mathematical operations. Then guys comes back propagation. So okay, this is essentially very important part, and I was explaining you this as well, that let's say you create a tensor in PyTorch, that is torch.tensor 2.0. So you're creating uh, a simple array that has one value, that is 2.0, and requires grad is equal to 2. So now guys, it's important this point, that whenever you write this parameter, right, requires grad, tells PyTorch to track the tensor. As I said guys, you would be doing a lot of back propagation and other complicated algorithms, and you won't be coding them from scratch. So essentially you are letting PyTorch do all those stuff for you, but it requires to understand that hey, it needs to track the tensor. So it requires this parameter, because this parameter will allow it to track the tensor and then later compute the back propagation more efficiently. Then guys, we are just creating a function y is equal to x square. So I hope you understand this. Then simple derivative example, I'm printing x and then I'm printing y. I don't see any problem. Then guys, once we calculate the derivative, this helps us compute dy by dx, and then we get the value of this x grad at 4. So x grad dy by dx at x is equal to 2. So let me just close it and I'll explain you what is happening guys. This is very simple only, you don't need to worry about all these things, but yeah, this will help you understand the basics very well. So guys, see what is exactly happening is, let me open notepad. So see guys, what we are essentially doing is that we are creating y is equal to x square. Okay, now the thing is, what is dy by dx? So dy by dx is equal to 2x, and x is nothing but x is equal to 2. So that is why we are getting 4, because 2 into 2 is 4. So I think guys, these type of things are very simple. Okay, these are not very complicated things, but to get started on, we need to understand this so that we can scale it up slowly. So all you need to understand is that whenever we are defining a tensor, we need to keep requires grad is equal to true, so that PyTorch can track this tensor. And then if you wish to compute the derivative, you need to use the dot backward thing. It's going to help you compute dy by dx, because y is a function of x exactly over here. And then if you wish to compute the value of the derivative at that particular point, so you can just write x dot grad, so you'll get 2x, and you remember, right, our x is nothing 2, so what we get is 4. So I think these type of things are clear guys, right? Now let's move to another example. So guys, whenever you are trying to move to a second degree calculation, so you need to reset your gradient. Okay, this is very important. So what happens is PyTorch accumulates those gradients, and that could lead to memory problems and other issues as well. So for the time being, just remember that whenever one round of back propagation is over, you just need to reset your gradients before the new calculation, so that PyTorch doesn't mess his system up. So for the time being, this one knowledge is enough. Later on, we'll understand it more better. So now, guys, let's just try to see what's exactly happening. So exactly what's happening is that we have this function y is equal to x square plus 2x plus 1. So now this is slightly a more complicated function. So what is dy by dx? Dy by dx would be 2x plus 2, and then it would be 2x plus 2, and the value of x is 2, so it would be 2 into 2 4 plus 2 6. So guys, I hope you're able to understand it, because these type of things are very basic, and yeah, you need to understand them. Just try to remember that you need to always zero gradients before new calculation. So in this lecture, essentially what you have learned is that how do you make tensors, right? How do you make tensors is dot tensor is important. Then when it comes to understanding gradients, you need to understand this y dot backward. Okay, this is going to help you compute derivative. Requires grad is equal to true is important, because it's going to tell PyTorch to track the tensor essentially. And then the next thing that you need to know is that x dot grad is going to give you that particular value. So I hope you're able to understand this, guys. Okay, now guys, we'll talk about gradient descent a bit. Okay, how do we do basic gradient descent? So see guys, it's very intuitive and straightforward. So what we are exactly doing is, we are trying to say that hey, we have a tensor that is x, that is going to take the value 5 and requires grad is equal to 2. So that means that your gradient computation will take place. Then guys, we are taking learning rate. If you would remember, in my NLP series I've talked about it, in my AI series I've talked about it, this equation, that's exactly very important. That's this equation. Okay, this is very important equation, that is how weight changes, right? Previous value minus learning rate into loss function, the partial derivative of loss function with respect to weight. So this type of calculation is very important. Then what we need to do is that we need to find the minimum of x y is equal to x square. So guys, you can understand this, right? So we are taking our function, then we are computing the gradient, then we are doing torch dot no grad, right? I taught you that over here, that we need to apply this no grad. That means it doesn't track gradients during update, so this is also important. And then guys, we are doing the learning rate, then we are resetting the gradient, and then it's gonna keep on going on. If you'd run it for more steps, it would probably just converge to 0, because that's the main idea, right? So slowly you're able to see how x was at this, and now it has more like big converge, slowly converging to 0. So guys, more or less, this is it for lecture 1. I'll give you a recap as well, what we discussed and what you need to know for lecture 1 specifically. So guys, when it comes to, let me just open it like this. So guys, specifically when it comes to PyTorch, what all you need to know for lecture 1 is that how do we play around with our tensors. So I mean, you won't be doing all these things with tensors. PyTorch would be doing it, but knowing that tensors are a fundamental part of a PyTorch and deep learning ecosystem, because it's going to help you accelerate mathematical operations, which are very important in any sort of optimization based problem. That's number one. Number two, guys, that I've taught you is how do we take a basic function. Let's say we have taken a basic function y is equal to x square, and then we compute its gradient and we make it 2x, and then if the value of x is equal to 2, then the value of dy by dx becomes 4. So how do we do that? In that, you need to remember that we need to take care of this parameter that requires grad. This is gonna essentially tell PyTorch to track the gradients. Okay, this is going to help PyTorch track the gradients. And then dot backward is important, because this is where the derivative calculation is happening. And then if you wish to fetch that particular value, you can use dot grad. So that's part one. Now we went on to discuss another little complicated example wherein y is equal to x square plus 2x plus 1. So what we did is dy by dx is nothing but 2x plus 2. Then the value of x was 2, so the value of dy by dx became 6. So this was simple example, but just giving you a short refresher on derivatives as well, since we might end up using that a lot. Then guys, we went on to discuss some stuff about backpropagation and basically basic example of gradient descent. So let's just try to break it line by line. So we have defined x as a tensor. That was fine. Okay, we have written requires grad is equal to true, because that's exactly what we need in order to track gradients. Then guys, we are setting up learning rate. Why do we need learning rate? So guys, see, what is gradient descent? Gradient descent is nothing but it's an algorithm that helps me find optimal value of weights whenever I wish to optimize any loss function. Okay, so usually when it comes to any ML based task, you would have a loss function which you need to minimize, and once you minimize that, you will find some value of weights or parameters, and that would exactly be your main thing. So what happens in gradient descent is there's this equation w new is equal to w old minus learning rate of change of loss function with respect to w old. So if you see it, what we are doing exactly over here is that we are taking multiple iterations. So let's say this is the loss function and this is the particular value that we need to get out there. So your loss function would become minimum over here. If you see and plot your any loss function, this is just a rough loss function. Okay, so your loss function is minimum, so you need to find out this value. Okay, so yeah, that's pretty much it. And exactly the main idea is that over here we are just doing a backward pass. Okay, then what we are doing is we are setting up torch dot no grad, because I don't want to track gradients during the update. And then I'm just trying to code up this equation so that I'll be just trying to get the updated value of x with respect to the gradient, and then we are just setting up the gradient to 0, because I said that we need to set gradients after every new calculation. So guys, this is a good understanding for our lecture 1. Even if you didn't understand some parts of it, just stay with me. I'm trying to take things from a very granular layer to more advanced layer, so there would be a lot of interesting lectures that would be coming up, and we would be deep diving into a lot of ML and DL based tasks, specifically with respect to PyTorch. And guys, very importantly, if I'm telling you this, just please trust me. I do believe that PyTorch would be one of the most demanded skill in future. It is the most demanded skill in future, but yeah, it would become very demanded. So just stay with me and have a great time, and please subscribe my YouTube channel. Thank you guys.